just a single shield together?
I didn't understand. You just wanted to use my calculator.
All right, guys. So again, we're going over this diagnostic test. If you have failed to do that or don't have it with you, again, you're going to do as well as you want to do. And I don't mean like I want to get a 5, I will. I mean, you might. I was sitting in here with Homer's last period. He dropped by, and I was looking over my 35, whatever. I looked over there. A legitimate 20 out of those 35, I think, can make 5s. And I kid you not, a legitimate 20. And all the rest have an opportunity to, they could still make a 5, because I've had people make 5s that I'm like, wow. But I mean, 20 out of there, I'm confident, based on what I know of them, have a solid shot at a 5. Now, right now, if you took it, I wouldn't make 5. So that's going to be up to you what you want to do with it. I have found every time you take a practice test and learn from your mistakes, you jump a significant number of points. And I mean a significant number. So you've got to re-expose your weaknesses. You have learned all the calculus. Doesn't mean you're not going to run into a problem where you're like, well, I haven't heard it worded that way before. But it's just a matter of exposing your weaknesses and then using this as an opportunity. All right, you've got your assignment sheet. You see how many different tests we're going to go over. If you're doing them at home when I ask you, and I don't ask you very often to do them at home. I really don't. Most of it we're going to do in class. But the few times I do ask you to do something at home, you really need to do it, or you're going to be sitting in class going, oh, I didn't even look at this problem. I didn't know what they're talking about. All right, so like problems like this on the diagnostic test, if you haven't done it, go home tonight and knock it out. So at least tomorrow. And remember, you have a test over these theorems when? Thursday, okay? And then again, on Friday, whatever it says to do, make sure you do those assignments and get those done for class, because when we go over them, that's where the real putting this stuff together happens. So first thing I want to do is just quickly go through the answers to this diagnostic test. And I don't even remember which ones. Let's go through the answers to them, and then we'll go over them individually if you want to see how they're done. And by the way, all of the solutions are in this book. Did you notice that?
Yeah, it's after the answer.
Yeah, it's got the answers. And so have you already checked the answers?
Mm-hmm.
Well,
Everybody already has?
It's terrible.
well, yeah, but I still have.
So you don't need me to say them, right? Okay, so I won't say them. Let's just jump into the actual problems. And remember, and also sometimes the way they do things is a little odd, because sometimes they'll solve problems by using the squeeze theorem, for instance. Well, APCalc just doesn't use the squeeze theorem. They don't require it. So I use a different approach to that. So sometimes sometimes they don't use a little trick. They're showing you some of the math behind the trick, which is maybe what a college professor would do. That's great. So some of it might look new to you, but that's really true about this diagnostic test. As we move through it, I think you'll see less and less. And also use this book. If you're like, man, I forgot everything about limits. Great, go look through the limit section, see if you can learn something. Oh, I forgot about L'Hopital's rule. Look it up, it's in there. There's tons of explanation in this book if you want it. But we're gonna focus after this test on Thursday, which guys, you really need to be studying those theorems if you haven't already. After this test on Thursday, we're gonna be doing just practice test and just going over this stuff. All right, so first question, anybody?
9.
Number 9. Okay, so number 9 says, it said f of x equals that. What's the value of the limit of the derivative of f? So first thing we got to do is do what? Find the derivative. Who remembers what the derivative of 2x e to the x is? This is totally not an AP looking question, but this looks totally unfamiliar to me as an AP question. So anyway, what would be the derivative of this function? Let's find that first. Do you remember how to find a derivative of absolute value?
No.
U times U to the derivative of U.
So U is, copy it down.
Yeah.
So the f prime would be, write it over here, would be whatever's on the inside. So 2x e to the x times the derivative of that, which would be the product rule, right? So the product rule would be first d second plus second d first. So 2 e to the x. Are you with me? Over what?
Over
The absolute value of that. Yeah, what you got?
Didn't you also write that as e to the x plus 2x?
E to the x.
Like change 2x e to the x to e to the x, e to the power of x plus 2x.
This part?
Just like,
You said, couldn't you change it to e to the x plus 2x?
no, like in x plus 2x, it's all in the exponent.
He's just talking about log rules.
Yeah, it's log.
Oh, there's no log here.
No, but I mean, shifting the 2x up to the,
For the exponent?
yeah,
It's not a log. You
Okay.
can't do it with the exponential problem. Is that what you're saying?
Yeah.
Yeah, if it was a log, e is not a log, e is 2.7. If it was the log of 2.718, which is the log of e, then yeah, you can use little swing rules like 3 to make it go there, but that's only with logs. There's no logs here. So don't do that. So that's my derivative, right? So this is, and that can be cleaned up probably a little bit. Okay, like you might be able to factor an e to the x out, right? Get 2x plus 2. There's different things maybe you can do to help you. But this is now saying to do what?
now just plug it as 0.
Plug in a 0, but just from the right side. So right here, this is totally not an AP looking question. If it were me, I would probably,
How so? Like, what,
it feels too ugly. It just
that feels too ugly?
Yes.
Oh, that makes me feel better.
If I factor out that e to the x out of that second part, and even the 2 out, I factor the 2 out and the e to the x out, I'm left with this, right?
Why factor when you just plug in 0? It doesn't seem that hard.
Now let me ask, well, hold on. Well, because I get 0 on the bottom and 0 on the top.
Oh.
Okay, so now I have to think about, well, what would happen now if I'm plugging this in, 0 on the top and 0 on the bottom gives me 0 over 0. So I'm feeling like there's a hole there, so I need to check from the right side. Well, what does absolute value really mean? I can't just cancel stuff that's in an absolute value and not in an absolute value. I can't just do that. But if I'm coming in from the right side, what is that?
The plus.
That's the positive side of that. So if I'm coming in from the right side of that, I can use the positive part of this absolute value. If I was coming in from the left, I would use the negative part. Does that make sense? Because absolute value has one behavior on one side, one on the other. So what that means now is, I could cancel the 2, I could cancel the x out, I even can cancel an e to the x out. And now what happens when I plug in a 0? E to the 0 is
1.
and 1 times 1 is 1. Is that the answer to this?
You mean 1 plus 1? Or no, 0 plus 1?
It's not 1?
But you still have to.
Oh, times 2. Sorry. So that's pretty ugly, but that doesn't feel AP-like to me at all. That feels way harder than an AP
That's
question.
test B.
Not even. But that's okay, because you just got exposed as a reminder to what do you do about absolute value. That's what this is about, just exposing weaknesses. All right, so if you remember, for absolute value, a definition is copy the inside, derivative of the inside, copy the original problem. And then you got a little reminder about from the right side, if it's the right side of an absolute value, just use what's in there. If it's the left side of an absolute, when you have an absolute value, change the sign of it. And then you can cancel now, but you can't cancel from inside and outside an absolute value. What else? Number 10. All right.
For sure.
So what's the rule I'm dealing with absolute with limits? You always do what? And if you didn't see me do that at the first problem, I didn't actively plug the 0 in, but I kind of did in my head. Like as soon as I found the derivative, I plugged the 0 in and I got 0 over 0. I didn't show that, but I did that in my head. I always do that first. So even on this one, I'm plugging the pi in to see what's going to happen. And when I plug a pi in, I get e to the pi minus e to the pi, and I get pi to the e minus pi to the e. So when that happens, I get 0 over 0. So what does that tell me to do?
L'Hopital.
I can do L'Hopital's rule. By the way, I could have done L'Hopital's rule with this one up here that I just did, but I didn't want any part of that because it was so ugly that if I were to do L'Hopital's rule to it, it would just become a bigger monster. But in this case, L'Hopital's rule works pretty great. And you remember L'Hopital's rule?
Derivative of the top over.
That's exactly right. And when can you do L'Hopital's rule? When you get 0 over 0 or what? Infinity over infinity. Now there's other things you could do too, but we don't have to cover those other ones. So if you ever get an infinity over infinity or a 0 over 0, L'Hopital's. So what's the derivative of e to the x? E to the x. What's the derivative of e to the pi? 0, because it's a constant, right? It's like 2.7 to the 3.14 power. That's a number. 0. What's the derivative of x to the e power?
No idea.
Yeah, you do. What would you say if it was x squared or x cubed? You'd use your power rule, right? Well, it's x to the 2.17-ish, right? It's ugly, I know, but what's x to the e then?
E times
E,
x to the e.
X to the e minus 1. It's ugly, but just roll with it. And then what's the derivative of pi to the e?
Nothing.
Nothing. So do this, recopy the limit, and now plug pi in, and what happens?
To the pi.
E to the pi over
E times pi to the e.
e times pi to the e minus 1. Now, my guess is it's not going to look like that in your answer. Okay? And my guess is this would be maybe a multiple choice question. Are there any like bases that you could combine? The e's. So what do you think this is going to end up looking like? What happens when you have an e to the pi over an e to the 1? E to the pi minus 1 over pi to the e minus 1. That's probably what the key says. Is it? Yeah. But if it was free response and you left it like this, that would be okay. But it's probably not going to be a free response. It's probably going to be a multiple choice question. And again, a lot of these questions don't really feel like AP questions to me. They just don't. But again, it's a diagnostic test. We're just exposing stuff. What else? Anything you missed?
For number 14, what is monotonic?
Okay, monotonic is a word maybe I've mentioned once. The mono part means it does one thing, and that means it's either only increasing or it's only decreasing. Okay? So if it's only increasing or only decreasing, that's monotonic or monotonistic. Sometimes they'll call it the same monotonistic. What number is that?
It's number 14. I mean, the rest seem pretty solid.
Yeah, so it's not monotonic on A to B.
But the other
The derivative is continuous on A to B, and the second derivative is positive on A to B. Yes, so 2 and 3.
two. Do number 18.
Okay. 18. Come on, man. Okay, it says if G is what? If G is the integral of that, which means what? The area from A to some value of X on its F function, and the graph of F is shown, it says above. Shown above.
Yeah, I didn't.
Yeah, it looks like the graph under 17 is part of 17, but I don't think that graph is not part of 17. Yeah, labeled as over that.
Okay, yeah, you're right. Okay, so that's the graph. If the it says right here, if G is the area of that, that's another thing you're not going to see is the confusion here. I mean, sometimes you'll see a set of graphs like here that go with the next problem. You're not going to see that on AP test. That's just annoying on this book. This guy's, it's just a cash cow for him. He just keeps printing the same book and calling it a new edition.
Should go to his house.
He does have a nice cover this time. It's not a paper. It's like this nice plastic. That was his upgrade this year. Whatever. All right. So right here it says, okay, if the graph above, which of the graphs is a possible graph of G? So I'm looking at the graph above, and I'm saying which of these would be G. So G is the area from A to some X value. So would this one make sense? Well, on this, what does it look like is happening? As I go from A to X, so as my X moves along, it looks like I'm doing what? I'm increasing my area. And then when I hit this, what does it look like I'm starting to do? Decrease my area, Right here, it looks like I'm increasing area, right? Like if G is the actual area, then it says, okay, right here the area is 0, because A to A is 0. And it looks like I'm getting more area and then less area. More area and then less area. That makes sense? This looks like I'm getting less area than more area. C looks like I'm getting less and then back to 0. Right? Looks like I'm going negative. I get negative area, then 0, and then positive area, then 0. But, and this looks like I'm getting a bunch of positive area and then even more positive area. So looking at those 4, what are you thinking? It would make sense that it would be A. That's very AP feeling to me. Okay, what else?
The way I did that one, I'm not sure if it's harder, is that if g of x equals the integral of f of t, then the derivative of g of x would equal f of t. So then you can just look and see that on the f of t graph is positive to the left of the.
So looking at it like slopes.
Yeah, and so then if g is the derivative, or if the derivative of g is the f, then you can do.
Oh, it is the relative max is 0.
So do you hear what he's saying? He's using that FTC number 2 and saying, if I took the derivative of this, I get G prime as F. So if I look at the slopes, if these are slopes, right, these are G's. So the slopes of these G's, the G primes, would have to be these F's. So right here, it looks like I have slopes that are getting what? Bigger and then to 0. Slopes bigger and then to 0. And then slopes what? Slopes of these are going from 0 to negatives back to 0, negatives back to 0. So it can work that way too. Are y'all seeing that? So you can think about it, if you use that FTC, you can think about it in terms of the derivatives of G, the slopes of this, comparing them to the values of this, or you can just think about it with areas. What else?
I had trouble with number 23.
Yep.
23. What is the slope of the tangent to the curve y equals cosine of xy? Okay, so to find the slope of the line, basically, it's tangent to that. I'm going to have to find slope. So how do I find slope when I got x's and y's mixed up? Got to find the derivative, and to do that, I got to do a little implicit differentiation. So let's get started on that. So the first thing is, if I take the derivative there, I'll do it right here. So I get dy
Over
dx. So the derivative of y is 1 dy dx. And then the derivative of cosine blah is what? Negative sine blah, right? Times the derivative of the blah. And how do I find the derivative of the blah?
1d2.
So first, d second, which is dy dx, plus second d first, and what's the derivative of x? 1 dx dx is just 1, right? Are we good? And now what do I have to do here? I got to get dy dx by itself, right? And then plug a 0 in. Now, if I want to, I can plug the 0 in right now and then just solve for dy dx. It's okay. You don't have to go through this crazy algebra. So if you want to do, if you think that's easier, go ahead and plug a 0 in now. It just eyeball, it kind of looks like it might be easier. Because if I plug a 0 in there and a 0 in there, a lot of this junk goes away. But if you wanted to solve for it, you could. So right here, I could say dy dx equals negative sine of 0, 0 times dy dx. Is the answer 0 on this? Yeah. So you can see right here, sine of 0 is 0, and 0 times that's 0. So I end up getting, negative sine of 0, which is 0, times all of this junk. All of it ends up just giving me a 0. But if it didn't, like if I had given you some other value like pi or whatever in there, in the end, after you multiply it all out, like hypothetically, what if I did say x equals pi?
What do you do with y though?
Well, the 0 times everything is 0. Because that's all 0.
0 times, yeah.
Right, but if I say it was pi, I plug it in there, it's gonna be negative sine of pi y times pi dy dx plus y. If that was the case, I'm gonna have to FOIL this out and factor out the dy dx. Do y'all remember doing that? So literally, I would have to go, all right, this is if, a big if x was pi. I would have to say, okay, FOIL this, and I get negative pi sine pi y dy dx plus negative y sine pi y. You tracking with me? This is what I would have to do. I would have to get all my dy dx's on one side, so I'd have to take that and add it over here, which would give me this. I'd have to factor out my dy dx, which would give me this. Do you remember doing these? Yes, no? And divide by that. Although, again, this would be very ugly. But when I do implicit, a lot of times I have to do that to find my slope or my derivative. But in this case, I didn't have to do any of that because when I plugged the 0 in, everything ended up canceling. Oh, and another thing you might want to be careful about, in this case right here, when I plug that dy dx, if I said x equals pi, I still need to know if x is pi, what does that mean about my y value? They wouldn't have done that. So normally, if I had said something like this, there's no way I can solve for the y value. Normally, I would have to find the y value that goes with that so I could find the derivative at pi whatever. Like normally, if they give you something, you need to find the point. But in this case, because they gave you 0, they made your life a little easier. Anyway, what else you got? Anything you missed?
25?
25. All right, velocity of a function of a moving particle is given by that function for time 0 to 6. What is the maximum acceleration of the particle on the interval? So to find a max acceleration, first I need to find what? Acceleration. And how do I find acceleration from velocity? Take a derivative. And then to find the max, what do I do?
Acceleration.
I'd have to take the derivative of acceleration, but be careful. And what do I do with that? Everybody answers this wrongly, but give it to me. What would I do once I take the derivative of acceleration?
Set it equal to 0.
I'm going to slope to 0.
Set it equal to 0, dE to find what?
Find
The critical numbers.
possible.
And then what do I do to find the max?
Plug that in and the endpoint.
That's what, plug that in the endpoints. Great. If you're thinking, oh, check on either side and see which goes positive and negative. If you do that, what are you finding? If you go plug in on either side, you're finding what? Relative maxes and mins. That's not a max, right? Relative maxes might be maxes, but if it says find the max, I take the critical numbers and the endpoints, plug them in. Don't forget about endpoints. So let's try it. What's acceleration? Acceleration would be,
T to the 4.
right, 3,
No,
hold on,
derivative, T squared.
right, so 3t squared over 3, so t squared minus 4t. So there's my acceleration. And to find the max acceleration, I'm going to find what? The derivative of that would be 2t minus 4. I'm going to set that equal to 0 and get 2. And I'm going to take that 2, that 0, and that 6 to do what? And plug them back into what? A of t. So I'm going to check A of 0, I'm going to check A of 2, and I'm going to check A of 6. And usually, and this is a great little calculus problem, our APCalc problem, plugging in a 0 in there gives me 0. Plugging a 2 in there gives me -4. Plugging a 6 in there gives me 12. So my max is 12. Now, if I said what are the relative maxes, that's when you do a little number line analysis, right? And you take your critical number in there and you plug in like, all right, let me check the Let me check the acceleration on either side of that and see what happens. Are you with me on this?
Tracking.
What else?
Number 30.
Could you also do 28?
Oh, yeah.
Yeah, we'll just kind of just keep plugging in order. So 28, given a differentiable function. Now, what's important about hearing the word differentiable? It's also continuous. If I say it's continuous, is it also differentiable? Why not?
Because you have cuts,
Corners, cuts,
go
could go vertical, right? Go vertical, it can go horizontal. It could go vertical, that would be undefined, right? So if it's differentiable, log it in your head, oh, that's also continuous. Okay, and then I also gave you this. What is this giving you? A point, and what is this giving you? A slope. So I know the point at pi over 2, and I know the slope at pi over 2. So using a tangent line to the graph at pi over 2, how can I do that? What is the line tangent to the graph at that? Y minus 3 equals -1 x minus pi over 2. So this will be all over the AP test, tangent line approximation step. Find an approximate value. So this is my tangent line to the graph, right? I want to approximate this. So what do you think? That is supposed to represent my f of x. Now it's not written in f of x, but that's representing f of x. So to find f of that, what would you do? Plug that in for x and solve for y. That's literally. Now, a lot of people would say, oh, well, write that as a function. I don't think that's necessary. But if you did, you'd have -x plus pi over 2 plus 3. So there's my function. So it's saying find f of pi over 2 plus pi over 180.
So it's pi halves plus a little bit.
Yeah. So if I were to do that, I'm plugging that in there, negative pi halves plus a very tiny little bit plus pi over 2 plus 3. It's probably easier to plug it in right there. And you can see when I distribute that negative, these cancel, and I get that. But again, if you had plugged that in right there, you would have just gotten pi over 180 with a negative, and then you would have just added the 3 over. So I don't usually rewrite it as a function, personally. I write that out clearly, and I'd probably say at x equal pi over 2 plus pi over 180, and I'd probably plug it in.
Is that an over approximation or not?
To do that, I would have to know something about the second derivative there. Because if I knew, if the second derivative, he asked a great question, which we'll run into. If the second derivative is positive, you know it's concave up there, right? So if I knew it was concave up there and this gave me a value, it would be under, the tangent line would be under the curve, wouldn't it?
Yep.
Right? So it'd be an under approximation. But if they didn't give you second derivative. If the second derivative was negative, that would mean the real curve is concave down, so your tangent line would be giving you values too big, right? You have a concave down and a tangent line like this, then it would be the tangent line would be over approximating. Great question that will get asked. I can almost guarantee you somewhere on this step. But you'll see it when you take these practice tests. What else? Oh, so 30? So it says f is the antiderivative, which means the what?
Integral.
The integral. So if I integrate this thing, that's f of x. So when I take, and it says, and f of 0 is this, find f of that. Now, I keep seeing you guys butchered this as a class. I mean, butchered it. When you get problems like this, and they want you to have f and f, how do I take a function and get back to f? Well, you're going to integrate it. But when you integrate it, you're always going from A to B, right? So if I want to if this is the antiderivative of this, then I have to think, okay, when I integrate this thing, when I integrate it from A to B, I'm going to get f of B minus f of A. I'm getting that. So you pick. What do you think I ought to use for A and B? why not use what they're asking you about, right? So let this guide you. So if F is what I get when I integrate this thing, I would get F of X plus C or whatever. But if that happens, that means that this is F of B minus F of A. Well, I'm going to use F of 0. And I'm going to use A equals 0 and A equals ln 2. And then to solve, all I have to do is what? Add that F of 0 over to this side. And I already know F of 0 is ln 2. So it's just a matter of solving this thing. So I get ln 2 plus whatever that is. Now, what do I do to integrate that sucker? U substitution. So let's do that. U, what do you want U to be? E to the x plus 1. And if you're a little rusty on your integration, remember, I got to make it look like one of my rules. So I'm going to pick the denominator, and usually that's where you go to first, because that takes care of that. And then when you take the derivative of u, you get what? E to the x what? dx. There's my dx. I forgot to write that in there. So there's my u, and there's my du. So all of a sudden I have the integral from 0 to ln 2 of 1 over u du. And all of that's going to be my ln 2. So what happens? Can y'all see this? I know I'm writing over the work there. But right here. So right here, to integrate that, what do I do? ln absolute value of u from what? 0 to ln 2. And yes, this strangely feels like something AP could do to you. And then now you just got to clean it up. So I end up with an ln 2 plus, what happens when I plug in ln 2 there? What is e to the ln of 2? 2. So you get 2 there, plus 1. And then what happens when I plug a 0 in there?
ln of 2 ln 2.
If I plug a 0 in there, I get 1 plus 1 is 2. So ln 2?
Yeah, that's what the 2 plus 1 would be.
Yeah.
Yeah. That's all.
Plug the ln 2
Yes, sorry. Yes. So ln of 2 and plus 1? ln of 2. Sorry. And then what happens? ln of 3. Is that my answer? So, yeah, I've seen stuff a little bit ugly like that, but the point is, if you have a link like that, if they say, hey, f is an antiderivative, and they give you a bunch of f values, set up your fundamental theorem of calculus. Right? Because that links the integral, the antiderivative, to the function. Y'all with me on that? What else?
35.
All right, so if f prime equals g of x, and g is a continuous function for all real values of x, oh yeah, I know what you're doing. I'm guessing all of y'all did,
I didn't know where to start, so
Yeah.
I just did.
I'm guessing most of y'all picked like C.
But I don't know why.
Anyway, okay, here's the thing. And I'll be totally honest, we didn't do a ton of problems like this, but we did do the basic. You learned this, right? Like when you integrate a g function from a to b, you get a new function, right? It might not be big G, but we can just call it big G, right? That's your fundamental theorem, right? What we didn't probably emphasize enough is this rule, sorry, forgot the dx right here. This rule is only true for x. It's not true for 4x, not true for 7x, not true for x squared. If it has any other thing in there, what are you going to have to do? Use substitution. So because I have this expression here with a 3x, this is true for x or for u, but not for 3. So I've got to do a u substitution. So if u is 3x, du is 3 dx, 3 1/3. So I get 1/3 g of u du. Okay? Are y'all with me? So when I integrate this, you know, it might even be, you might even do this right here. If g of x is f prime, why not just put that in there? And then it'll make nice, clear sense to you. When you integrate an f prime, what do you get? F. So now I get back to 1/3. I get f of u, let me need that, from 0 to 2. So 1/3 f of 3x from 0 to 2. Where does that leave me? 1/3 f of 6 minus 1/3 f of 0. Y'all seeing that? It's so easy to just do the f of 6 minus f of 0. Every year on the AP test, when these problems show up, it'll show the people who got it right, and then you'll get feedback on each problem when they ever release these things. And the vast majority of misses do this, because people look at this and they go, "Oh, well, that's just f prime of 3x from 0 to 2." And if they just do, f of 3x from 0 to 2, they just do this and they get f of 6 minus f of 0. But remember, your rule, that rule right here only is true for a single x. Do a u substitution if you see something different. What else?
37.
Anybody else? We can keep plugging through there. If we skip in one that you want to do, make sure you jump in there. 37, if a function f is continuous for every value of x, right, which doesn't mean it's differentiable, it says which of the following statements is or are true. So what is this essentially saying right here? The integral from a to c of this continuous function is the integral from a to b of it plus the integral from b to c of it. Is that true or false?
That sounds right.
Yeah, because this is saying that total area from a to c is the sum of the two parts from a to b and b to c. That feels true to me. All right, what about this one? The total area from a to b is a to c. I'm sorry, the integral from a to b is the a to c minus the c to b.
Oh, that's not
No.
easy.
So let's think about this. If this was a and this is b and this is c, they're saying, we could just think like this. They're saying this area right there is the same thing as the total minus c to b, but that's going a different direction, right? So one way to make that make a little more sense would be to change this from b to c and do what? Make it a plus. And now a to c plus b to c is not a to b, is it? So does that make sense what I'm saying? So that's out. And then 3 says b to c, which is this part area, is equal to a to b minus minus c to a. Well, again, c to a is like a to c made positive. So if I take this right here and add a to c to it, does that give me b to c? No. So what would end up being true? Just number 1?
Well, it's 1 and 3.
Three is B to A, not A to B. You go B to C.
Oh. A to b negative. Sorry. So, sorry about that. So a to c, the total, minus a to b leaves me this part, and that's b to c. Sorry about that.
So that was a multiple choice here in the book. What kind of work did you get to show? Or would you just copy it?
That's always a multiple choice question.
Wait, can you go through number 3?
Yeah. So the biggest thing I would encourage you to do on these is get them all going in the same direction. So I missed it right there because I looked at it, I just saw a to b, but make them go the same direction. So this is really going from b to a. I don't like that, so I'm going to make it a to b and make it a to c and change the signs because that's a rule we've learned just recently. And then you can see that, hey, the area under the curve here, this area right there,
Okay, wait.
is the same as the total area minus that part. And that makes sense.
That makes sense.
So fancy. Everybody with me? Jack, you need some sugar, man? Load up, come on. All kinds of snacks.
Want some nerds?
Still got some chocolate.
Somebody snagged that whole bag of Reese's. Oh, no, there it is. Whole bag. Man, I'd eat that whole bag if I wasn't 53. I'm going to the beach. But try to feel, stoked. What else you got?
46.
Kind of a dime. Number what?
46.
I agree with that.
Have you tried CrossFit, Missouri?
No, dude, that's just a good way to get injured at my age. Everybody I know that tries CrossFit. How you doing? How's CrossFit treating you? Oh man, I hurt my back. How's CrossFit doing? Great, man. Awesome.
What about like kickboxing?
Still, that didn't inspire me.
You could be like that host.
Some push-ups, occasionally.
You and then Mike Tyson is on the ground.
Have you seen Tyson lately?
Yeah.
No.
Dude, he decided he got in the back of the ring with a guy, but he got in shape. Dude, he went from being just like, like on what's the movie? Not Bachelor Party, but The Hangover.
Yeah.
He's in a couple of those, man. Huge gut on him. Now he's jacked again. Pretty good for, I don't know how old he is.
He should have won it, but like no one's on the
Yeah. Anyway, 46.
46.
What is the average value? Okay, guys. These are the easiest problems on the front. And maybe I'm saying that and that ends up being tricky and I'm not seeing it. But if it says average value of blah, then what do?
The integral from
You integral the blah from A to B over
B minus
B minus A. So if I want the average value of that, I'm going to integrate that from negative ln2 to positive ln2 over what?
negative ln2 minus.
Oh, no, A, this is A and B. So from A to B over B minus A. Now, if you miss this because you forgot how to use substitute.
Yeah.
But don't miss it. And that's okay. It's still early. But don't miss it because you don't know the average value definition. So now, for average value, how do you integrate that?
God.
Well, it's not a rule. Your rule is e to the u.
Yeah.
So it's e to the blah. What's your u going to be then? So if your u is negative 4x, then your du is negative 4 dx. So I need a times negative 4 times negative 1/4. Right? So now I've got negative 1/4 on the outside, the integral of e to the u du over, that's going to end up being 2 ln2. And then what happens here? What's the integral of e to the u? E to the u. So I end up getting e to the negative 4x, and with a 1/4 out front, actually a negative 1/4 out front, all of that from negative ln2 to positive ln2, all of that over a 2 ln2. What is their fascination with ln2? And then I got to just plug and chug, right?
Not pretty.
So it's not pretty, and again, doesn't really feel very AP-like, but the process, the questions are, it's just the algebra gets uglier. This is like 1993 AP questions where every bit of algebra was awful. So plugging it in, we can do this though, watch. E to the negative 4 ln2. So 1/4 e to the negative 4 ln2. And then minus a negative 1/4 e to the positive 4 ln2, right? Because when I plug that in there, it becomes a positive. All of that over a 2 ln2. Yeah, this is very 1990s AP like. So what can I do to clean this up? Can I cancel that e and the ln? Great question right there. Can I? Not yet, but what can I do? I can move that negative 4 up. Then I can cancel the e and the ln, and that leaves me what? So I'd have a negative 1/4 and a 2 to the negative 4, which is 1/16. And then these two negatives cancel. And then what about here? Can I cancel that e and the ln? I can move the 4 up. Then I can cancel. This time I get a positive 1/4 times a 16. And all of that, horrible. And whatever the algebra gives you on that thing. Don't expect to see something this algebraically nightmarish. That gives a negative 1/64. That's a 4.
Yeah. What are we doing? I know it doesn't-
Do y'all have any more questions on this?
48 through 50, I know how to do them.
All right, if you have any other questions, like if you did not do this yet and you go back through and have other questions, we can do that. If not, I'm going to just take the time to actually talk about some of those theorems, maybe make sure you're remembering certain things, talk about some of the questions on that packet if you have them. Yes?
You say these.
So, we're going to the ARPA Friday, and it says multiple choice test A, or what is it?
Yeah, I haven't given you that yet, so I will print that before then.
That's not in this book.
That is not in this book. So I will print that, make sure you're either here today or tomorrow, and I will give you that first practice test.
So these diagnostics questions, would you say these are like around the same difficulty level as the AP test? Or harder?
I would say some of them are close. I would say the algebra that you see is probably a little trickier on this thing. Because again, these are the same questions that were on there 10 years ago. I mean, nothing has changed. Except that he actually went from 5 options on multiple choice to 4. He eliminated one, which is, what AP has done recently.
Do you have that whole book?
I don't have it on me. It's in my other room. I just got to go get it and print it. But yeah, the topics are great, are good topics.
I guess that was terrible.
And keep in mind, guys, you don't have to make an A on this to make a 5.
What was it, like 70-ish?
Yeah, a 70 on most of these tests, give or take, is a 5 out of 108 points. So just think about that. What did you say? There's no reason not to grab some?
Yeah. I mean, it's here.
Yeah. Paid for.
It was weird decimal, and it was exactly right.
You can start selling them.
Like, I just forgot to spell it.
Like the
For what?
coffee bar.
I miss the hurry podcast so much.
Yeah,
Oh.
it's a good thing. Who knows?
Will it come back?
I don't think you can do that.
Oh, I'd bring it back if it was,
Normal.
if you were allowed to share a coffee pot or share a mug.
Yeah.
It's just too much trouble for me to have to wipe stuff down every period.
No. That's right.
See ya.